Okay. So, good morning, ladies and gentlemen. My name is Jiří Navrátil. I'm working for CESNET, Czech Education Network. And I should chair this session, which is called the Open Flow. And we have 3 talks, as usual. And what to say to Open Flow? So it's the phenomena in networking today. Seems me like other very popular words in this, I would say. So, and it depends on the near future if the open flow will follow the way of grid and clouds, or if would be something else. And the first speaker is Bartosz Belter, who is working for PSNC, the Polish Supercomputing and Networking Center from Poznań. Maybe you know him from participation on several FP6 and FP7 projects. He is working as a senior programmer, and his focus on architectural aspects of control and monitoring management planes in the optical network. So, Bartosz, you can start your talk.
Thank you very much for the introduction. Good morning, everyone. My name is Bartosz Belter. I'm from PSNC. I would like to talk a bit about the problem of federating SDN islands with an extended NSI framework. So just a brief introduction to the SDN concept, a well-known picture. The SDN, in principle, separates the data path and the control plane, and this allows us to provide programmability of network control. And this might be done as a separate instance deployed somewhere else, talking to the equipment, data path equipment, through the OpenFlow protocol, which is at the moment the one of the common tools in SDN. I'm not saying it's the only one, but at the moment it's the most popular one in SDN. So what my talk is about? The first question I would like to raise is how to enable inter-domain flows between open flow islands, open flow domains. So let's see what we would like to achieve. The principle is simple. We would like to establish communication between application endpoints deployed somewhere in the network, and we expect the path to go through multiple OpenFlow domains. So this is the goal we would like to achieve. So let's check how it may work in practice. So let's see how it works in the first domain on the path. So we have the application endpoints attached to the network. So the application starts transmitting packets. This packet is handled and the first switch on the path and is passed to OpenFlow controller. So as you may see, OpenFlow controller takes a decision whether the path should be established or not. So in case there is no problems, OpenFlow controller configures the path for the packets. It sends the packet to the outgress interface. This is a nice feature of OpenFlow. So the path is established. Okay, well done. The first step is done. Let's see how this works in the second domain on the path. So we have the packet coming to the first switch on the path. So similarly, it's handled by the controller. So the controller makes a decision, configures switches, and sends packet to the egress interface. So the packets go through the network. Well, it looks quite simple, but the point is the multi-domain flow processing that simple? I think something went wrong. So let's see again what we have done and what assumptions we made. So the first domain on the path, application endpoints attached. The second domain on the path, everything set up. So we established the path between the two endpoints. Well, but how these controllers know what exactly we'd like to achieve? What if we are surrounded with multiple domains around? So how to make a decision, arbitrary decision, how to send packets from one PC to another PC through these specific two domains. What if there is alternative path which is with a lower cost between these endpoints? So definitely we need some, let's say, logical communication between OpenFlow controllers to make this decision. Yeah, that's the clue. We need a synchronization protocol between OpenFlow controllers. So let's look at this picture. This is let's say, the new SDN architecture, the first approach. So we have multiple domains controlled by OpenFlow controllers, and we identify the problem. We need some kind of inter-domain communication protocol between these entities. Well, what might be a requirement for this protocol? Well, we need to abstract the topology we have in the domain. We need to advertise our abstracted topology to other domains. We need a signaling, and we need a path computation engine inside these controllers. And we need to have some feedback from the network about monitoring. So for all of you familiar a bit with bandwidth on demand system development, deployment, this picture might look similar. Yeah, so what we see, we can adopt the NSI framework, which provides exactly this functionality to the network domains to provide communication between OpenFlow controllers. So the NSI supports network topology abstraction. The NSI supports topology exchange. The NSI itself, it's an inter-domain signaling protocol, and path computation is supported. And NSI, there are tools within the whole NSI framework which provides monitoring functionality. So we are done. Yeah. So let's have a look at the refined new SDN architecture. So on top, we have network applications. These applications may talk to the SDN, generally speaking, through the SDN API. And this is something what I marked as not defined yet. There are some efforts with integration, this SDN concept with OpenStack, in example, but I would not say this is a standard, but this is not the subject of my talk. So let's look at the SDN architecture inside. So definitely we have intra-domain controller. This is what we see nowadays. We have these controllers inside, and what we propose to put another component within this architecture. It's inter-domain controller to communicate with other SDN domains. So we consider extension of the concept with two protocols. The first, we call it, it's a working version of working name. At the moment is the NSI SDN protocol to communicate with other SDN domains. And we have an internal protocol to communicate the decisions to intra-domain controllers. And of course, below we have OpenFlow data plane. Well, the second problem appears if there are some carrier networks between OpenFlow islands. And to be honest, that's quite realistic, because if we are talking about research networking, we may consider OpenFlow islands deployed at universities. These universities then are connected through NREN infrastructure to JAND, and possibly through other NREN infrastructure to university. So we have several, let's say, non-OpenFlow domains on the path. So we need to have some kind of mechanism to inform the carrier domain about the traffic characteristic we would like to send through this domain. So we need to have a mechanism to push towards these domains. An example saying that we need a specific VLAN tagging through your domain. So if the NSI is exposed by an operator, why not use it? And that might be a typical use of the NSI connection service, well defined, and you saw on some demos that it's quite well deployed and it's quite popular in research environment. So if we look at this problem, we may notice that the reactive mode, it's not possible. If we put any BOD implementation In the path, we cannot assume that these BOD systems do have OpenFlow-like protocol. So there is no feedback from the data plane towards BOD. So reactive mode, definitely it's not possible. But there's a possibility to have a proactive mode. So the flow, before we start the transmission, actual transmission, we need to advertise the flow to neighboring domains. And the open question is if the hybrid mode makes sense. So let's look at once again at the architecture. So if we have the carrier network in the middle between SDN domains, definitely talking to another SDN domain, we can use the NSI extended SDN protocol to communicate the message flow. So this is what I was explained before, but at the same time, we may use NSI connectivity service to inform the domain about the traffic characteristics. Then the SDN domains are going to be configured with OpenFlow, while the carrier network or even a chain of these carrier networks might be configured using SNMP, CLI, whatever the platform is deployed in the network. It must be said that we may use not only NSI. We are in a research environment, and the NSI protocol is quite widely deployed. But if this is the operator domain, telco operator, if it exposes, that's the open question, if it exposes the UNI interface, we may signal the network, GMPLS network, in example, and this will work. Okay, the title of my talk is a federation of SDN islands with NSI. But so far, I just explained the problem of inter-domain OpenFlow, how to configure inter-domain OpenFlow. So no federation efforts so far. So now it's time to introduce the Felix project. It's a new project. What I explained before is one of the drivers for the project, not the only one. It's a collaboration between Europe and Japan, and the ultimate objective is to create a common framework for future internet experimentation research. So among the other objectives, we use the objective to utilize the OpenFlow and NSI for creation federation SDN services. But this is not the only objective. We plan to create the integrated Europe-Japan SDN testbed. We plan to introduce new APIs for seamless provisioning of IT and network resources. And what's more important, we plan to facilitate Europe-Japan collaboration on new standards. Just a quick look at the architecture. So at the bottom, we assume there are NSI-controlled domains, GANT domains, including NRENS and GANT itself, glyph NSI domains, and JGNX NSI domain. On top, we have the OpenFlow islands deployed in Europe in several countries, Spain, Belgium, Germany, Poland, and Japan. And on top of this infrastructure, we plan to put the Felix SDN Federation Framework. Among other features, NSI-oriented, we plan to work on the resource management, one of these red components. You can't read this properly, I think. So resource management, the experiment control and management, and the monitoring framework. So just to conclude, the NSI framework, what I was trying to explain, seems to be quite well suited for the inter-domain SDN scenario. And when we are talking about interoperability with carrier networks, we believe that a standard use of NSI connectivity service is a possible solution. When we are talking about reactive and proactive scenarios, it looks that reactive mode is possible only if we have OpenFlow domains on the path. If we bring any non-OpenFlow domain, this brings us to the proactive scenario. And word about Felix, a few words about Felix. I'm at Felix at the definition of the federation framework, which allows us to interoperate between multiple SDN control frameworks. And we propose a new way for creating inter-testbed connectivity using the NSI framework. That's all. Thank you very much.
We have plenty time for the question.
I was.
So, okay, go ahead.
So this is a very interesting talk and a very interesting initiative. When do you think you will have this testbed online?
So the idea is that we have testbeds already deployed in several countries, and this is the current status. We use also Ophelia testbed. This is what is brought to the project by several partners. So on the Japanese side, the testbed is up and running. So the project just started. So now we are going to have a discussion, huge discussion on how to federate these testbeds. So first step is an architectural discussion, but in the meantime, we plan to proceed with the implementation. So we are checking possibilities, how to connect European platforms on the data plane level with Japanese platforms. I'm expecting to have first results early next year.
Okay, I have one more question which is connected with this. Can you tell us which institutes are involved in these projects? So you said the countries, but if you have more details.
So on the European side, PSNC is coordinating this project. We have involved iMinds, ITUCAT, AICT from Germany, the coordinator of Ophelia, Nextworks, and sorry if I miss someone, yes, and SurfNet. So 6 partners on the European side. On the Japanese side, we have AICT as a project coordinator on your Japanese side, and KDDI.
Okay. So some more questions about this? Okay.
Hi, hello. Yeah, that's really interesting what you presented. I have a question. You mentioned 6 partners. Is also, or exists also the idea to interconnect the share of OpenFlow facility equipment that we have established in the Xeon 3 project?
So it's not in the roadmap, but since we are starting the project right now, we are open for a discussion. So definitely this will bring a value. As I tried to explain, we will have several domains, OpenFlow domains deployed in Europe and Japan, and now we are thinking how to interconnect them. So one possible solution is to use the NREN infrastructure, the JANT infrastructure, and that's why we are pushing towards the NSI, the standard use of NSI. But if there is OpenFlow domain within JANT, we may consider using this as another island to be used.
Yes, I think this would make sense in this way, that you, and so if you need some contacts or a contact, so please come to us and we will support you.
Okay, definitely. Thank you for your offer. We'll take it into account.
Okay, maybe I didn't listen carefully. So it's the project which is in the frame EU-Japan cooperation, which was opened quite recently, or not?
Yes, that's the project which is just starting at the moment. It's in the FIRE initiative, and it's for the collaboration between European and Japanese researchers.
Okay, thank you. Some more questions? Okay. So, thank you very much, Bartosz.
Thank you.
Okay, our second speaker, Otman. He's Palestinian, but he's studying in Japan. He studied in University of Kyushu. He is student of my good friend, Professor Akamura. Maybe you know him. especially, I mean, the Japanese. And he will talk about some aspects of OpenFlow, which probably it's part of his thesis for PhD. Okay, you have a floor.
Yeah. Good morning, everyone. So my name is Othman. I'm studying in Kyushu University as a PhD student. So today I will present our work that is titled as Aiding OpenFlow Controller by Enhancing OpenFlow's Control Model and Behavior of Some Flows. So first, for the outline, I will be starting with the motivation and goals, and then I will explain about how and why did we try to enhance OpenFlow, and then evaluation and conclusion. So for the motivation, so currently OpenFlow is like very active area for research, and many people are predicting that OpenFlow can have good applications for in the future and for future internet as SDN technology. But also OpenFlow can there's a debate about OpenFlow's scalability because of the controller. So because there's tight coupling between the OpenFlow controller and the switches, because everything has to be done in the controller. And also in case of the switches, so some people think that the resources, for example, the flow table entries or the size of the flow table is limited on the OpenFlow equipment. So we think that there might be a bottleneck in the network because of this. And so we tried to think a little bit in the future. So if we have like many different applications that are using OpenFlow, for example, some YouTube video on demand or IPTV, VoIP, and many other things, security. So that means we're not thinking as currently like circuit-based OpenFlow things, but we're thinking like more different applications that have different needs and different ways to use OpenFlow. So that means the controller will have to handle lots of things. And so our goal is to like kind of improve OpenFlow and make it more self-reactive, and also reduce load on its controller, because everything has to be done in the controller. So we must provide him with somehow like to be able to still work under some heavy pressure and while relying on the network for some parts. And we hope that this will work as a like fail-safe mechanism. So for example, if the controller is under heavy load and many applications are asking to install new flows to the network, then the controller can just throw everything to the network, and the network can handle that. And after that, when he's not so heavy loaded, then the controller can check everything and put things into order again. But the main point is the controller will still be work under high load conditions. So we propose two enhancements for OpenFlow. First one is network equipment to equipment flow programming or flow installation. And the second one is a new type of flows, which is proactive flows. So I will explain the first one. So currently for OpenFlow, so everything has to be done from the controller to the equipment. So that means the main communication is between the controller and the equipment. But in case of regular, I mean like more centralized way, but in case of the regular routing algorithms and things, so it's fully distributed. So we want to make like hybrid model, but of course, OpenFlow is not like that, but we want to propose this only for some special cases, which are the cases for overloading. So it's not like we're doing this all the time, only when it is needed. So that's our target. And how this can be useful. So it can be useful to, for example, if there are some the controller is overloaded and it receives many flow installations to be installed by applications to some specific equipment, then it will install everything directly to that equipment, and then this equipment will cooperate with each other using the equipment-to-equipment flow installation, and they can distribute the load among them without having the controller to interfere with this. So currently, like, the controller have to manage everything, and it have to distribute load and many stuff. But if the controller is overloaded, then it will just throw things away, and the network will handle that. And a second useful way for taking some load off the controller, which is in the current model, like the controller have to control flows. For example, if you have to control the same flow to the whole network, then it will have to send the flow to each equipment one by one. But if we use the proposed equipment-to-equipment flow installation, then it can ask equipment to program each other. So that's another difference. And for the third one, which is proactive flows. So for the current OpenFlow, the flows are activated, or they are used as soon as they are installed into the equipment. But we think that maybe a little bit different method will be more useful. So if we consider the case of virtual server migration, so if we have a server on this machine and it will be migrating to another machine, and it wants to keep the same IP address and such similar cases. So in that case, the OpenFlow controller must make some redirection in order to keep the IP address on the new machine, and while still receiving the requests from the clients, I mean, without disrupting the service. So in that case, if we think of the regular OpenFlow, so the flows will be activated as soon as they are installed into the equipment. So in that means that the controller must specify or must install the flows into the OpenFlow equipment on the exact time that the migration finishes. Or because if it installs first, then the request will not reach the appropriate current server. And if it was, for example, overloaded, then probably the flow will be delayed, and the new requests from clients will not be answered, because it reached the old machine, not the new one. So we propose to have proactive flows that are installed into the equipment before they are needed, like some time before they are needed, and they will be activated by some 3 methods. For example, like explicit activation packet or activation flow, that is using another flow to activate this flow, and preset time. So that means the controller can, when it has plenty of time, then it will be installing this proactive flow into the network, and it will be used or it will be triggered or activated on the right time, for example, by another flow. And after that, it will be used. So that means that the controller doesn't have to keep very precise timing to install flows, so it can just send it ahead of time, and it will be activated on the right time. And for the evaluation, so we are currently using Omnet ++ simulation, so to compare regular OpenFlow and the modified OpenFlow. And for the first scenario, we considered that we have some equipment that are having too many flows to be installed on them, and but under one condition, that is the controller doesn't have to do everything by itself. So it will just throw flows, and the equipment have to handle that. And for that case, we will count the number of flows in the flow table. And for our simulation, we considered the case of this topology, and we chosen some nodes that are highly connected, for example, like central or nodes that most control most of the traffic for some region have to go through them. And for our evaluation, so this is the case of regular OpenFlow. So you can see that the number of flows are growing rapidly. So it can reach up to, sorry, it's not very clear, but yeah, more than 100 flows. But if we use the OpenFlow network equipment flow installation, so it can be fixed on some value, which is in this case maybe around maybe 30 or similar value, but it's not growing because the equipment are cooperating with each other. But this is under one very important condition, that this is done without the control of the controller. So equipments are doing this by themselves. And for the second case of evaluation, which is unfortunately still under processing, still going, so we're considering the case of proactive flows. So we will have like two cases. First one is using the modified OpenFlow or the enhanced one. Second case is regular OpenFlow. So we will measure the time between installing flows and using them, and we will count the number of unanswered requests for both cases. And we hope it will be promising. And for conclusion, like, we hope to reduce load from the controller by modifying the OpenFlow control model and behavior. Just so, as I said, it's not like a big change. It's mainly for the cases that it's really needed. So we hope that it will be very useful to OpenFlow. Thank you for your listening.
We are ahead of time, so we have time for questions. So I open discussion to this talk and to generate. Maybe. Nobody? Okay.
So one aspect of this potentially is that a device or a network could be put under a denial of service if you can generate or know what type of flows to generate to cause the load. Have you put any consideration into that?
Yeah, actually for that one, we're still under like studying. I think you have a very good point, but if we think like there's some central point or predefined way for exchanging security information, or for example like public keys and things like that, then it can handle that case, but under that condition only. I think.
Okay. More questions, comments, recommendations? Nothing? Okay. Thank you very much, Utman.
Thank you very much.
We are going to the third talk. Third talk would be from the industry. So we believe that it will the different view on the open flows. And the speaker is Robin Massing from the Cian Incorporation, United Kingdom. He's
So, this one?
working as a management, or he's doing managing the growing system, Cian system in EMEA. That means in that region. Okay, so it's,
Okay.
Robin, you can start.
Thank you very much. Good morning, everyone. First of all, I'd like to make a little apology in best Oscars style. Our designated speaker couldn't be with us today, so you got me. Never mind. The good news is that the content and the concept they're going to show you today remain exactly the same. So the agenda, SDN, why does it actually matter? Why all the fuss? Why all the interest? I thought we had a party last night. I thought you'd all still be in bed, which is it's great to see you here. Data center versus the metro and the WAN. I think one of the previous speakers touched on this already. And that is that most of the interest so far around OpenFlow has been inside the data center. So what Cian are doing is looking at what's happening in the carrier space, okay, in the metro and in the WAN. So what does a metro SDN system potentially look like? So we've got an architecture that we'd like to show you. I'd love to get your feedback. I'd love to get your thoughts on this. It's our proposal. It's our thoughts. We want yours. We also have a booth upstairs, so feel free, if you don't want to ask questions now, if you're a little bit shy, come up to the booth and talk to us. We really want to hear what you've got to say. And then we're going to take a pragmatic look at a few SDN applications and actually show you a proof of concept that we've designed and built And we're actually going to be showcasing that proof of concept at the Interop event in Tokyo next week. So keep your eyes open for that one, please. Okay, so what's all the fuss about? Where's the value? Well, there are a lot of obvious values in SDN in fundamentally separating the control plane from the forwarding plane. We can innovate quicker, we can virtualize, and we can improve the user experience. Cost, of course, is a big play. So we can improve the cost model. We can bring down the cost of actually deploying next generation networks. I was talking to a carrier only a few weeks ago at another show, and he actually said to me that a next generation network is another way of saying more for less, in a nutshell. So more cost efficient networks, better use of resources, and simplifying the whole operation, simplifying the whole turn up, rollout, and management, and assurance of those networks once they're up and running. So let's take a look at a few of the differences between the two, between the metro, or the data center rather, and the metro. So the data center is quite a nice place to be. It's quite a controlled environment. It's predominantly Ethernet and IP, whereas the carrier space, we're talking about both packet and optical technologies. So straight away, it's multi-layer. The data center, again, it's relatively homogeneous. So you could almost call some data center deployments greenfield. You know, you see these data centers popping up all over the world right now, and they're being built from the ground, literally from the ground up, in a very structured manner. Whereas what we have in the carrier space is an evolution. We've got all sorts of packet and optical equipment. We've got legacy equipment that service providers quite simply just can't write off. So we have to think about that too. How are we going to bring the whole thing together? And then the control plane. So looks like we're standardizing on OpenFlow as that's the control plane protocol of choice in the data center, which is great. But over in the carrier space, we've got all sorts of other control plane protocols to think about. So we have to think about how we're going to handle those and the equipment that we're talking to, because remember, some of this equipment will never have an OpenFlow stack on it. It will never happen. So we have to think about all the equipment that's already deployed, that's already out there. We're not going to just redesign the entire network. If you think about what the whole OpenFlow project was about at Stanford University, it was how would we build networks today if we had a blank sheet of paper? If we started from absolute ground zero, how would we build them? And that's where OpenFlow came from. We don't have that luxury today in the service provider space. We've already got a huge install base that we have to think about. And then finally, the OS. So OpenFlow integrates nicely with the Cloud OS. What the service provider has to think about is those huge OSS, BSS systems, those back-end systems that they've made massive investment in. So actually, to quote, I think it's Peter Veenstra at KPN, their lead architect, he came out with a quote only last week with reference to his speaking slot next week at the SDN event in Barcelona. And he basically, what he's saying is that the biggest single problem that they have to crack is the OSS problem. Okay, so that is a big issue for service providers. And then finally, we want to glue the whole thing together, end to end. Not just the data center, not just the service provider space, the whole thing from a services point of view. So this is the approach that we've taken at Cyan. We've designed an SDN platform. It's called Blue Planet. What we've done is we've opened up a host of northbound APIs. We've developed a few of our own applications up on the left-hand side. Things like management tools in terms of planning, operate, design tools, and also SLA assurance tools. And then we've given the service provider the option, the opportunity to design their own tools. And then finally, we come back to the OSS integration piece. So we're working with OSS vendors to integrate with their solutions too. And finally, southbound is a tough nut to crack. There's a a whole host of vendors that you can see there that all have their own proprietary methods of talking to their own equipment. If you like, they've all developed their own bundled solutions in terms of control plane and forwarding plane. So we have to think about not only OpenFlow, but SNMP, NetConf, TL1, et cetera, et cetera, et cetera. And so we've got an adapter factory that basically turns out adapters for all of these vendors according to service providers' service specifications. So moving on, let's talk about virtualization and orchestration. So one of the cornerstones, again, of SDN is simplification. So point and click, end-to-end provisioning, a clear association of the services and the underlying transport layers. So we want to see the service end-to-end, but we also want to understand what resources we're using to build those services across the network. We want to offer virtual networks, so we might want to offer the customer the ability to see and manage their own virtual network. But again, we need to know what's going on the underlying layers, what fiber, what lambdas, what OTN wrappers, and carrier Ethernet-based services that we're offering to them in return. We've also developed numerous apps to make visualization of those services very simple to understand. So this one's the trail analyzer, so we can literally see point to point both a logical and a physical view of a single service across the entire network. And again, this one's a cable viewer, so we can drill down into a single fiber and take a look at every OTN wrapper, maybe a carrier Ethernet service, maybe a tunnel that's inside that fiber at any one time. Of course, now we've built a network, we're managing the network, we need to assure that network. We need to make sure that it's running properly. What's becoming more and more table stakes is SLAs and the ability to guarantee those SLAs and show that the service provider is adhering to those SLAs. So we're seeing the use of customer portals, so customers can actually see that they're getting what they paid for. And like I said, this is actually becoming table stakes with a lot of carriers now. So that, if you think about the portal, a portal would be, usually it's seen as a passive tool. What we've actually done is made it an active tool and given the user the ability to, for example, turn up bandwidth. So that's now a remote tool that that the service provider can offer to their end customers. So networks as a service. So we hear this phrase thrown around a lot in the industry as well right now, alongside SDN and OpenFlow. And what does it actually mean? Well, usually we're talking about Ethernet services, and usually it means, okay, we'll offer you a VLAN. But if we can monitor, if we can manage multiple network layers and visualize those multiple network layers, it actually opens up a whole host of other wholesaling opportunities for the service provider. So we're not just talking about Ethernet services anymore. We could be talking about a Lambda, or we could be talking about an OTN wrapper, or anything in between. So if we can visualize it, if we can understand what resources we have inside the network in a deterministic fashion, then the service provider can then offer that as a service. So I want to take a look at this particular scenario. So this is the enterprise to cloud connectivity scenario that we've been working on recently at Sign. I think it's pretty much a given these days that an enterprise can log on to a service provider's website or a VDC and say, I want X amount of compute, I want this many virtual machines, and I want to turn them up now. So this piece over here is kind of done. We virtualized the data center. You can just turn up resources as and when you need them. So what we have is the ability for an enterprise to log onto a portal and turn up compute. What we don't have today is the connectivity in between, across the WAN or across the metro. That's the piece that's missing. So whilst we can turn up compute in the data center almost instantly, we may wait days or weeks for the connectivity to be turned up. So this is a problem, if you like, or a challenge that we've been working on. And this is the proof of concept that I want to show you today. So customer logs on to a portal, says I need X amount of compute or virtual machines. I want this type or this quality of connectivity into any one of a number of possible cloud providers. So this could be more than one data center or more than one cloud provider. And then once I hit the top of the rack, using OpenStack, I then want to allocate virtual machines and resource. Now, this is, again, it's not easy. Remember, this is a multi-vendor network, using multiple standards, multiple protocols, across multiple layers. So this is the proof of concept that we're actually going to be, as I said, demonstrating in Tokyo next week. This is the end-to-end view. So you'll notice that we're using open standards. So one of the fundamentals, again, I think, of SDN is to keep it open. So we're using OpenStack, and basically we're using Quantum and Nova APIs, again, open, to touch the enterprise segment, the carrier segment, and the data segment to bring up an end-to-end service offering. What does it look like in practice? So we've taken the Dell server. In the carriers piece, we've taken Obsidian NIDs, some Cyan Z-series, and some OpenFlow-enabled Arista switches in the top of the rack. It's multi-vendor. That's the point I want you to see with that slide. So that's phase one. We're going to be demonstrating an enhanced version of this in Tokyo, as I said. And then phase two is an even bigger challenge. I'm looking forward to seeing this one. And that is a more complex carrier network. So you can see we've now got an MPLS core. We've also got a Metro ring over on the left-hand side, a G8032 V2 Metro network. And then we've got a CPE, a layer 3 router, or a layer 3 device actually in the data center. So we're now orchestrating across the entire piece in a much more complex environment, again using Quantum plugins and OpenStack as the umbrella tool, if you like. So, closing thoughts. Benefits of SDN in the WAN environment. Well, I've already mentioned lots of innovation. You can see the innovation that we're trying to bring into the industry from the previous slide. Lots of differentiation for service providers so they can offer new services to their customers. Vastly improved economics. And orchestration across the entire piece. And that's the big one. You know, being able to orchestrate end to end. So we're trying to make the whole thing a service-aware exercise as opposed to a piecemeal chunk at a time. Let's bring this service up. Maybe it'll take 2 or 3 weeks, and maybe we might get the actual services that we're looking for. And at the end of the day, the enterprise, they really aren't concerned about what technologies, what the underlying technologies that we're using. They're more worried about their quality of experience. How does it actually feel to use these services, and how easy and how quick is it to turn them up? And finally, use cases. Well, as you can see, that what we've done there with the proof of concept is converge the transport piece and the cloud piece. So I think we'll see this happen more and more now. This blurring of the distinction between the two network areas. Application-aware networking. A coordination or an orchestration of all of these resources. So this umbrella orchestration piece across the whole of the network. And finally, of course, once we've brought these services up, we need to be able to assure them, we need to be able to monitor them, we need to be proactive. And that's it. Thank you very much.
Okay, we can open the discussion on the question for Robin.
I have actually 2 questions. The first one is, what is your target customer group? Because from your presentation, I see you are targeting different customers. So is it required to deploy all your components on the path from data center owners, metro networks, core backbone network operators? So how can we take these results and deploy them? And the second question is on the inter-SDN interoperability. So can I deploy my stack and talk to your stack, SDN stack, through some interfaces?
So to the first question, You don't have to deploy purely Cyan hardware. I think that was the question. This is a multi-vendor scenario. We're very much a multi-vendor organization. I don't know if you remember the slide earlier on that showed all the vendors. We've built adapters for all of those vendors. So it's not just a Cyan Z series.
But if there is an operator in the middle, an operator in the middle interconnecting my data center sites, what are the requirements I need to expose to this operator to make this happen?
Okay. So that's where the orchestration piece comes in. That's where Blue Planet comes in. Yes, we have an OpenFlow controller, which today we're targeting actually at the data center, because if you think about it, that's where all the OpenFlow capable equipment is. All the OpenFlow enabled, all the equipment that carries an OpenFlow stack today is in the data center. So we're not pointing it at the WAN today. That's an orchestration piece. So, and you can see that from the amount of work we've done in integration, there's no magic bullet. There's no single solution to this. So the WAN piece tends to be more of a case-by-case basis. So we start with the data center in terms of OpenFlow, and then yes, as we get more and more OpenFlow-enabled equipment in the WAN, then that makes life a whole lot easier for us. Okay?
Okay, are you happy? So somebody else? If not, so I would, okay.
Hi. So one of the interesting things I saw yesterday in the, I can't remember the specific session, was there's a lot of the NRENs are trying to get together and come up with general agreements to make good deals with the likes of Microsoft for access to Azure, companies like Box, these types of providers. And then in parallel with that, we see NRENs like Janet, for example, which is my NREN, doing a deal with Microsoft to get a nice peering to their services. I think it's in Dublin. So how do you see these types of principles fitting into that? Do you see that there'll be these large strategic deals made and then the NRENs forming their own peerings, expecting long-term relationships? Or do you think things could be more on demand and access to those services where they require specific bandwidth and capabilities will be done like this? Or do you think it will be the classic find good peerings opportunistically where you can? How do you see that sort of developing?
So we have put some thought into this one. And so I'm sorry if I keep going back to the service provider, sort of the commercial arena. I'll try and bring it into the education and research arena. So how we see this working is that the service provider, in this case Janet, would become a broker. So your enterprise customers are actually maybe possibly the other NRENs or campuses, and they would log onto your portal, and then you would be able to offer them, as the service provider, a choice. So give your own customers choice of which cloud provider they want to use for whatever services. They might have particular services that they want, and Azure might offer a better service than another cloud provider, for example. So you offer your customers the ability to choose which cloud provider they want to go with. So in a commercial environment, this is actually service providers like this, because if you think about it, the service provider is now getting paid by the enterprise for the portal and access to the WAN, but also the service provider is getting paid by the cloud provider for the brokerage service. So it's a good model. It's a good model, and it works in both your environment and in the commercial environment. So it's definitely something that we're going to do and we're working on. But it opens up new possibilities, and this is what I think. This is one of the things that SDN is all about. It's opening up new possibilities, new service types that we haven't even thought of yet. So this is one of the good things. This is a great thing about being here today. You know, this is why I want to hear what you've got to say. Okay.
So, more question? Yeah, so this is a classical question if the academic environment, the academic networking should make these things by home, or if they should buy some existing commercial solutions. So, but as I I'm working in the academic environment for 30 years, so I know that the academics are special, so they always want to own solution because the commercial is a little bit not fit into the academic environment. But so I think it would be also in this open flow and virtualization and all this stuff. You know, so this is my opinion. Okay, so seems me we are very effective. So behind the open flow was simple idea, of course, how to simplify, how to make the flexible networks more easy, and so how to improve the efficiency. So we prove it now in our session because we finished 3 talks in time for 2. And I would like to thank you to all, and I would like to invite you on the plenary session, which will start after 1 hour. So you have a time for the coffee. Okay, thank you very much.